Welcome to our channel. Today, we're diving into the top 10 fascinating facts about the beginning of Earth. From its humble beginnings in a swirling cloud of gas and dust to the dramatic events that shaped its destiny, we'll uncover the captivating story of our planet's formation. Get ready to explore the fiery birth of our planet, the colossal collisions that sculpted its surface, and the emergence of life on this remarkable world we call home. Our story begins in a giant molecular cloud, a cold, dark nebula teeming with the raw materials for stars and planets. This vast expanse of space is filled with gas and dust, lying dormant for millions of years, waiting for the right moment to spring into action. Imagine a swirling mass of hydrogen, helium, and heavier elements, remnants of long-gone stars, scattered across trillions of miles. These elements, forged in the hearts of ancient stars, are the building blocks of everything we know today. A subtle disturbance, perhaps a shock wave from a distant supernova, causes the cloud to collapse under its own gravitational pull. This shock wave travels across the cosmos, triggering a chain reaction that sets the stage for the birth of a new star system. As the cloud contracts, it spins faster, like a figure skater drawing in their arms. This increase in rotation causes the cloud to flatten into a disk, concentrating most of its mass at the center. The core heats up immensely, igniting nuclear fusion and giving birth to our star, the Sun. This process releases an enormous amount of energy, lighting up the surrounding space and marking the beginning of a new era. Surrounding the newborn star, a protoplanetary disk of leftover gas and dust continues to swirl where our planet will take shape. Over millions of years, these particles will collide and stick together, gradually forming the planets, moons, and other celestial bodies that make up our solar system today. In the early solar system, countless planetesimals are locked in a cosmic dance of collision and growth. Among them, in the habitable zone, our young planet began to take shape. As Earth's gravitational pull grew stronger, it attracted more planetesimals, adding to its mass. These collisions released tremendous heat, melting the young planet's surface into a fiery, molten ocean. As Earth cooled, heavier elements sank to form its dense core, while lighter elements rose to create the first hints of a crust. This early crust marked a crucial step in Earth's evolution, paving the way for the oceans and continents that would shape its future. Imagine a young Earth, its surface a molten sea of magma, constantly bombarded by debris. A Mars-sized protoplanet named Theia, on a collision course with Earth, hurtled through the early solar system. This head-on collision vaporized Theia and blasted huge amounts of Earth's mantle into space. The impact created a vast, swirling disk of debris around our planet. From this cosmic collision, a new celestial body emerged, our Moon. The Moon, forever linked to Earth, shaped the destiny of both worlds. In the aftermath of the Theia impact, the space around Earth was a chaotic maelstrom of molten rock and fragments. Gravity began to exert its pull, and particles collided and stuck together, growing larger. Over time, this process sculpted a new celestial body, our Moon. The early Moon, still glowing hot, orbited much closer to Earth. As the Moon cooled, its surface became a canvas for countless impacts, sculpting its familiar features. The Moon's gravitational pull stabilized Earth's rotation, preventing drastic shifts in its axis. The Hadean Eon, named after the Greek underworld, paints a vivid picture of Earth's early years. Imagine a world shrouded in a thick, toxic atmosphere, its surface a hellscape of molten rock and volcanic eruptions. During this period, Earth was still reeling from the impact that formed the Moon. The atmosphere was a toxic cocktail of volcanic gases, devoid of free oxygen. Asteroid and comet impacts were commonplace, delivering water and other volatile compounds essential for life. The Hadean Eon laid the groundwork for Earth's future, setting the stage for the emergence of life. As the Hadean Eon raged on, Earth began a gradual transition from a fiery inferno to a more stable planet. Central to this transformation was the solidification of Earth's crust. Imagine a time when Earth's surface was a vast, interconnected magma ocean punctuated by volcanic islands. As Earth cooled, this magma ocean began to solidify, forming the first fragments of a stable crust. These early crustal fragments, known as cratons, were small and constantly reshaped by volcanic eruptions and tectonic shifts. Over time, these cratons collided and merged, forming larger landmasses. As Earth continued to cool, a remarkable transformation took place: the formation of its first oceans. The source of this water is a subject of ongoing scientific debate. Some theories suggest that Earth's water was delivered by comets and asteroids. As Earth cooled, its atmosphere began to clear, allowing water vapor to condense and fall as rain. This rain eventually collected in the planet's lowlands, forming shallow, steaming seas. The formation of Earth's oceans marked a profound shift, providing the environment for the first single-celled organisms to emerge. Just as Earth was beginning to find its footing, forming its first crust and oceans, a period of intense asteroid and comet bombardment known as the Late Heavy Bombardment unfolded, reshaping the young planet's surface. The LHB, which occurred approximately 4.1 to 3.8 billion years ago, was a defining era in Earth's early history. This cataclysmic event was triggered by gravitational interactions between the giant planets, such as Jupiter and Saturn. These powerful interactions disrupted the orbits of countless asteroids and comets, sending them hurtling towards the inner solar system, where they collided with Earth and other terrestrial planets. The impact rate during the LHB was staggering, with Earth struck by hundreds, if not thousands, of large asteroids and comets. These collisions released immense energy, creating vast craters and altering the planet's geology. While destructive, the LHB may have played a crucial role in the development of life by delivering essential ingredients. Asteroids and comets brought organic molecules and water, which are vital for life as we know it, potentially seeding the early Earth with the building blocks of life. The LHB serves as a reminder of the dynamic and chaotic nature of our solar system, highlighting the interplay of cosmic forces that have shaped our planet. Despite the chaos, Earth eventually stabilized, setting the stage for the emergence of life in its primordial oceans. Today, we can look back at this tumultuous period and appreciate the resilience of our planet, which has endured and thrived through such cosmic upheavals. Amidst the chaos of the Hadean Eon and the Late Heavy Bombardment, the emergence of life occurred on our young planet. This period was marked by intense meteorite impacts, volcanic eruptions, and a hostile environment that seemed unlikely to support life. One prevailing theory proposes that life originated in volcanic hydrothermal vents, where heat and chemicals spew from Earth's interior. These vents provided a unique environment, rich in minerals and energy, which could have facilitated the complex chemical reactions necessary for life to begin. Another theory suggests that life may have originated in shallow pools of water on Earth's early surface. These pools, often referred to as the primordial soup, were rich in organic compounds and subjected to energy sources like lightning and ultraviolet light, which could have sparked the formation of simple life forms. Regardless of its exact origins, life emerged on Earth remarkably early, perhaps as early as 4 billion years ago. This early emergence indicates that the conditions necessary for life were present almost as soon as the planet itself had cooled enough to support liquid water. These first life forms were likely simple, single-celled organisms, marking a profound turning point in our planet's history. These microorganisms were the pioneers of life, capable of surviving in the harsh conditions of early Earth. With the advent of life, Earth would never be the same, setting the stage for the evolution of the incredible diversity of life we see today. Over billions of years, these simple organisms evolved into more complex forms, leading to the rich tapestry of life that inhabits our planet now, from the deepest oceans to the highest mountains. For billions of years, Earth's atmosphere remained largely devoid of free oxygen. Then, around 2.4 billion years ago, the Great Oxidation Event occurred. Photosynthetic cyanobacteria began releasing oxygen as a byproduct of their metabolism. This oxygen eventually began to accumulate in the atmosphere, transforming Earth. The rise of oxygen paved the way for the evolution of more complex life forms, including multicellular organisms. The GOE transformed Earth from an oxygen-poor world to the planet we know today, with its oxygen-rich atmosphere and vibrant diversity of life. The story continues. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content about our planet and the universe. See you next time. See.